our fabulous chemistry students.
That was Milks.
And that was MoNaCo.
Yep.
He almost tricked me.
I know y'all been asking, so we've been, we on our game now. We're trying to get some more homework videos up for you.
Yeah, enjoy this short one because the next one's going to be low.
Yes. And kudos to those of you Utes who are doing it. If you've been figuring out the practice based upon the lectures, and it shows.
And that's really what the game is. Come check your practice when you're done. Make sure you did it right.
Not only that, but you're going to finish the unit ahead of time, which leaves more time to make up labs and review for the final exam.
Perfect. Here we go.
Awesome. Page 13.
Branches.
Branches. Those are things out of trees, mister.
Kinda, and it's going to work the same way here. If you consider the parent chain or the backbone, the trunk,
right?
We might have some side chains or branches of carbons, some number of carbons hanging off.
And we're really not going to go past 2 in
Probably
our
not.
practice.
I don't think so.
And we're not going to have multiple branches in our practice, just because we're keeping it simple.
There's a few dimethyls, I think.
Okay. Either way,
not a ton.
Not much more than that.
Of course, the parent chain is the longest chain you can count without picking up your pencil.
Right.
So, and you'll find sometimes it doesn't matter which way I go. The bend doesn't count. It doesn't matter.
Right.
It doesn't have to be the branch.
Multiple bonds in the parent chain dictate which way to number the chain first. The side chains are second. So if you're looking at double bonds and triple bonds and side chains, you need to remember that the parts of the hydrocarbon of interest have to have the lowest number first. So you find your double chain, your double bond, make sure that's like number 2 or 3. Then, after you number your carbons after that, you would number the side chains based upon that. So
that numbering system doesn't flip-flop.
You'll really see it when we show you.
There you go. So here's an example. So we're going to walk our way through naming this bad boy.
Prefixes tell us how many carbons are in the parent chain. Should I pick up a pen and do a little writing, or do you animate it?
It's not completely animated, so we might want to write.
Okay.
So again, how many carbons?
Well,
1, 2, 3, 4, 5, 6. Look it over table P, find 6, and we are a hex. So let's get that side chain thing taken care of. Okay. Now, the root tells us in the parent chain how we're bonded, right? And we see all single bonds, so that's an ane. So this is going to be hexane for our parent chain. Next, name the side chain just like the parent chain as far as number of carbons. So the side chain in this case is going to be above the 2. 1 carbon is a meth, and it says to replace the ane with an il, so I know that it's a side chain.
Right.
So that's going to be a methyl. The YL lets me know that it's a side chain. The meth telling me it's a side chain of 1 carbon.
Let me rewrite this.
Okay, and then the last piece is the number tells us which carbon it is. So we have methyl hexane, but I don't know if it's 1 methyl, 2 methyl, 3 methyl. So the 2 tells me that it's on the 2nd carbon. So we can go backwards from this now. Perfect.
Again, to recap real quick, if your branch is 1 carbon long, it's called a methyl.
If it's 2 carbons long, it's called an ethyl.
And if it's 3 carbon long, it would be a propyl. But I don't think we did many of those.
No.
And the number that comes out in front of it all just tells you which carbon your branch is hopping off of.
That's it.
This could have been 2 methyl, 3 methyl, 4 methyl.
No.
Because then we'd have to number from the other direction.
Correct.
So this could have been a 2 or a 3 methyl hexane.
Right, and if there's no such thing as a 1, because then it would have, my carbon chain would have just been bigger, and it would have become heptane.
Heptane. And it wouldn't have been a 4, because then I would have numbered from the other direction, which would have made it a 2 methyl.
Right.
Again.
Oh, and hey, since we're here and we mentioned heptane,
Yep.
This is an isomer of heptane.
Right. We'll see that in a video later on.
Sweet. Here we go.
Let's keep trucking.
All right, do some more examples. Okay. Okay, first one is 2,2-dimethyl butane. So let's start with the root. I see butane. So but is 4 carbons. Notice that we're going to go, this process is the same for every one of these, no matter how big and bad it looks. Ane tells me single bonded.
So I don't have to draw any doubles in there. That's good.
Nope. And then it says 2,2-dimethyl. Well, dimethyl is 2 methyl groups, each of them on the second carbon. So there's one, there's two. Let's fill in our hydrogens and we're done.
Oh boy, here come the H's. Why don't you start talking about the next one?
Okay.
The molecular formula.
All right, yeah, so it's C6. Oh, you're putting them all in, huh?
Oh my gosh, I hate this part.
Yeah.
That's why they created condensed structural formula.
This is true. I was just doing the practice packet. For some of the functional groups, I do default to the structure or the condensed formula.
Right.
And some of my kids are already learning the shortcut on this.
C6H what?
Ouch, count them. 3, 6, 9, 12 plus 2 is 14.
Because it's an alkane homologous series. I can
Yeah,
use
but-
the general formula.
Yes.
No double bonds, no triple bonds.
Yes.
Branched hydrocarbons still obey
Yes.
the alkane homologous series general formula. And it is
Saturated.
saturated.
All right, good. All right, next one. We got to count our carbon chain. To be honest with you, counting right down the middle is going to give us the same number either way. So let's just count it right down the middle. 1, 2, 3, 4, 5. 5 gives me a pent. All single bonded is a pentane. Two functional or two side chains, each is one carbon, so they are both methyls. So that is a dimethyl, tells me there's two. One's on the second carbon and one is on the third, so it is a 2,3 dimethyl pentane. Molecular formula looks like 5, 6, 7 carbons.
I'm going to guess, is it C7H16?
Yes, because you used your formula, which works in this case because there's no double bond.
And it is saturated. That's why my formula works.
There we go. There we go. Next one.
Oh, wow.
Longest carbon chain.
So if I started here,
2, 3, 4, 5. And if you start at the bottom and go up, you're still going to come up with 5. 2, 3.
you're right. So I'm going to stick with the green
I would.
as my backbone.
I would. And you can count both ways to see, but that's one of those things you almost want to count in your head. So pent is 5, and ane is single bonded. Okay, and my side chain now is 2 carbons. So instead of a methyl, it now becomes an ethyl. 2 carbon side chain is an ethyl.
And it's coming off
The third carbon, so it's 3-ethyl. Pentane. Molecular formula 5, 6, 7 carbons. It's all single bonded, so I'm guessing there's going to be 16 hydrogens and it's saturated.
Now, this is what we started talking about, isomers. If you look at 2,3-dimethyl pentane and 3-ethyl pentane, if you look at the structural formulas, they're very different.
Well, the names are, and then the molecular formulas are exact.
Right. So, and they're both saturated. We call these two things
Isomer.
isomers, which means that they have the same molecular formula,
Different structure.
different way the atoms are connected.
Right. Different structure means different behavior. Different
Very common when
properties.
dealing with hydrocarbons because there's so many different ways
Right,
to
just
arrange
move
them.
Move a chain around. If you look, you take that bottom ethyl on methyl on the first one, put it up on the other methyl, and you got it. So here we go. I got hexane is 6 carbons single bonded. 3-methyl is a carbon side chain of 1 on the third carbon. Fill in my hydrogens, and we're off to the races. How about you leave that one like that? Because my kids are starting to get a hang of this. I told my kids you can't start leaving off the H's until you can't get it wrong anymore.
Yeah.
When you get to the point where you can't get these wrong anymore, then maybe we can start
I want to
leaving
see
out
you
the
fill
H's.
in all your hydrogens.
Yeah, I really do want to see you fill in all your hydrogens.
Formula?
Formula, I got 7 carbons, and I'm single bonded, so look at this, H16, another isomer. Isomer. Remember, same number of carbons, hydrogen, same number of atoms
Yep. Just the way they're connected to each other
is different.
is different. And now you can start to see why carbon is so important and different and diverse.
Because I can take the same number and build all sorts of different things.
It's like the same kit of Legos. You can make a billion different things out of the castle,
You know?
not just
Make a
structures.
boat and all sorts of stuff.
Carbon's great, man.
Yeah, it is. So,
So-
here we go.
Recognize, name, and draw hydrocarbons with branched side chains. This goes into our nomenclature piece.
Yep. Table P helps us with our backbone, how many carbons.
Mm-hmm. Table Q tells us about the homologous series, the root, if it's a double, single, or triple bond.
Right? And then the number in front tells us where that difference is. If there's something different than a normal alkane straight carbon, wherever there's something that varies from that basic piece, the number tells us where that particular variance is.
Off the back.
Here we go.
Thanks, everybody.